have we have planned introduction session. That's the module 1. Okay, so now we treat it as module 1. Actually, this is the module 1 I prepared, but that will be module 2, and that way will be sort of module 2. So, so basically, decarbonization and why now, green steel making concepts. That's the topic for this module. We are going to discuss more decarbonization. I know that one of steel, although I know there are a lot of power plants, but again, as we discussed in the beginning, that there is a connection, that we need to know that because power you are feeding and you are generating lots of power for steel industry or for other industries. So in this case, maybe you are, I don't know how much familiar you are with the steel industry. I think good to be aware of that. Make sense? Okay. So it's not power focused, so I cannot probably promise because later modules will develop a little bit on power focused, but this will be more steel focused. But ultimately, yeah, we help each other. And two industries are very much linked. So before I start, any remarkable thing you learned this morning which you didn't know? Anyone contribute that you learned something which you didn't know before?
The LCA.
LCA is kind of newish. Okay, we will go more into deep into that.
ECWW.
ECWW, that's one word. Please do not forget me, but not ECWW either. We call it energy carbon water waste. Actually, we kind of popularize that term. The reason is that there are so many indicators you can evaluate, but these are the ones for industrial application. They say 1 kilowatt hour of power, isn't it? That's that's the power unit is 1 kilowatt hour, isn't it? Right? Electricity unit. So or 1 megawatt hour. What is the ECWW unit? If you think about that, imagine yourself that okay, we want to know and determine. At the moment, can you determine? Can you calculate ECWW? Probably not. What are the techniques? And once we have the benchmark, then you need to know the pie chart, where they're coming from. So we call it a hotspot identification. So once you have the hotspot, then okay, we attack on that first and then next, so that we can overall ECWW footprint is reduced. Okay. So now this module, we're going to talk about steel makers. Obviously, just broad picture of steel making by country, by company. What's the use of steel? You know that. By the way, any idea which metal in the world, in terms of volume or mass of production, is the highest? Which metal? Any idea? What is the number? How many tons?
It is 1.93 billion ton.
1.93 billion ton.
Yeah.
So that means nearly 2 billion ton of steel is produced in the globe.
Yeah.
So that was last year's stretch.
Yeah.
Yeah. As I said, when I started my career, it was less than 1 billion ton, and it last maybe a decade or so, it became double. Okay. What is the next metal do you think? Aluminium. Do you know what's the magnitude? I think now it's probably 80 million tons, something like that. Primary aluminium, and even for secondary aluminium, but ultimately primary, what we were talking about, primary steel production and second kind of that way. And what's the next? Copper. Yes. Probably, do you know how much? Around 35 million tons. So you see, and the next one, I don't know, manganese maybe? I don't know. Or is that, I think very likely manganese and then lead, zinc, and others, other kind of alloy element. So if you talk about steel, we're talking about 1.9 billion, right? 1900 million. Next one is aluminum, is 70, 80 million. So it's a drastic drop, isn't it? So steel is the largest metal. So that's why I think a lot of our work in the past we have done. What is the specific carbon footprint of a ton of metal? Do you know what is steel? You said about 2, isn't it? 2 ton of CO2 per ton of steel. Aluminium, any idea?
It's a target.
Aluminium? Any idea aluminium? Aluminium, it depends. Global average something is 10. But if it is coal-fired power station is used for making aluminium, it is 20 per ton of CO2 per ton of aluminium. So how many times more than steel? 12 times. An order of magnitude higher, right? So, but I think aluminum industries, so some people say that for 1 ton of aluminum you produce in coal-fired power plant using coal-fired power, you make 22 plus tons of CO2. So it's a CO2 production factory, not aluminum is a byproduct. So sometimes they joke. Yeah. So but it is kind of, because aluminum is very electricity intensive process, aluminum production. That's why. If you switch that electricity to some renewables or others, you can drastically reduce. Now, so 1 ton of metal, 2 ton of CO2, 1 ton of aluminum, 20 plus ton of CO2. So you multiply 1 ton times 2 billion nearly, and so 2 times 2, nearly 4 billion, isn't it?
Yeah.
So whereas aluminum, even it is very high, 24 times maybe 70 million. So even global average is 10, as I said, because global electricity is mixed. So it's a 700 million, something like that. So overall, so one is the specific footprint, another is overall footprint because of the total production in the world. So if you want to reduce the CO2 footprint of metal, where should you focus then? Steel. Because even though concentration is low, but because the magnitude of steel is so high, it kind of dwarfs the other metals. So these are the things. If you say gold, what's the CO2 footprint of gold? Any idea? And how much gold is produced in the world? Any idea? Roughly 2,000 tons, plus minus. It depends on that. And majority of the gold, do you know where it is used?
No.
Mobile phones. Now, yet that's right. But majority gold use our sisters during our wedding, they gold jewelry. So it's half of the. That's why Australia produces a lot of gold, and majority India imports a lot of gold. Obviously, particularly wedding seasons, gold demand is up and etc. But gold also, the gold amount of gold is produced in the world. Most of them are already kept somewhere, either as a gold jewelry or the bank, because a lot of countries buy gold. Because when I started my LCA of metals, gold, one of the study, nobody reported. Some companies, gold companies, maybe they study, but they don't report. So we are the first kind of paper we published on the CO2 footprint of gold. And one of my that student I talked about, still not good. And he said the price of love he calculated. Basically, gold ring, 3 grams of gold, it is 22 carat. And he calculated it has got probably 100 kilogram CO2 and even a small gold ring. And this sort of bottle is how much? It's half a 500 ml. So 1,000 liter, that means 2,000 bottle like this in your ring. That much water required to make a gold ring. So and then waste is very high, 1 gigajoule of energy, because gold is, so globally 2,000 ton of gold is produced, but their ECWW footprint, particularly waste, because 1 gram per ton gold ore compared to iron ore. Any idea what's the grade of iron ore? What's the iron content, iron oxide in iron ore? Any idea? 60%. So we are talking about gold is very, very small. Majority of the metal, actually we call it waste to product ratio. Majority of the metal, the product is very small, waste is very high. Except steel, aluminium. Aluminium is 44%, something like that. Copper is 1%, going down. Nickel, zinc. So majority of the, so in the mining business we call it materials or metals distributed in the ground as a ore or deposit, small quantity. Our job is to enrich that and make it high grade and then sell it as a pure gold or pure copper or pure iron. And the companies who use it, they distribute again back in the mobile phones a small amount, here a small amount, there is a small amount, so distribute back again. So basically, low grade to high grade will get produced and then comes back and distributed. So you need to get back again. So that's why the story of the recycling comes back. So metal industry is really, really fascinating industry. And if you look at each metal and how they produce, so we're talking about a little bit of the steel industry. And the steel, majority of the, if you talk about the structure, big structure like bridges, anything you cannot do, like chairs, anything structural material. Transport, trunks, etc. Without steel, you cannot think of our life. Okay. So steel is one of the major. And then carbon emission problem, decarbonization of the grid. We might talk a little bit about that. So power industry colleagues might get a bit of flavor of that. What are the potential solutions? Obviously, that's the objective. So So solutions is not easy, and we might think about solutions. It may not be cost effective today. Maybe we need to evaluate that. But whole job, a lot of people are coming with solution. But what's the proof that solution is right? What's the quantified values? That's what we are here for. And we need to have some sort of understanding to evaluate solutions. And sometimes waste utilization is one of the solutions. So maybe we can talk about it a bit more. So that's your figure is set. So that's the top 20 steel producing countries in the globe. And you can see China, 1 billion. So majority of the metals, I think when I started my career, at least it was distributed. Now, in China, in that aspect, everyone gets out because they cannot make money. But good thing, India is not that situation. India is another kind of Chinese-like entity. We can have big industry and low base big demand. So you can see India 140. Is it? What is that Indian? Anyone has latest? What's the Indian? Last year 145. And I understand target is 300 by 2030. Is it 300 billion? Do you think India will get there? No. What is the problem? Why not?
Delay projects.
No, so projects are mostly delayed somehow. As far as I know, mostly what is happening is acquisitions are taking place without effectively
New
increasing the
production,
capital.
new growth. And so only 5 years we have got. So another 150 million, so every year 30 million ton added. No way, yeah?
2035 maybe.
Maybe. So but is that we don't have demand, or we have demand and we cannot produce enough?
So we have another target also.
What is it?
2047. 500.
So that's so we moved the goalpost.
No, the demand is there. The
Demand is
there
here.
demand.
So
Because
there is
we are importing a lot of steel from South Korea, from China. We are importing a lot of
That's
steel.
right.
The demand is there.
Demand.
Somehow we are able to not.
So maybe, so I think, but ideally government wants to use that import.
Yes,
demand, right? That's obviously local jobs, etc. So if we can do it, but it's challenging.
Yes, sir.
And we understand that. Yeah. So good thing, interesting thing, Australia. What's the interesting thing about Australia?
They are not producing
They are
steel
not
production. They are supplying all our raw
Is
materials.
1 million ton, 1 billion ton. Maybe we produce 80% or 70% of their own.
Yeah.
Same with Japan. All Japanese steel mill our own. All Korean also use our own kind of. I think that's Korea. I don't know. There's Hong Kong. Maybe there is Korea. I don't know. Korea is significant also.
Korea.
So on top of it, so that's like South Korea 66. Yeah, that's right. Russia, they have their own. Russia is a bit disconnected. But if you talk about in the past, steel production was the indicator of wealth or development. You know that US used to produce a lot, not much. Europe used to, and any country per capita still indicates that that country is, because they need development, buildings and everything else. So India per capita steel production is still pretty low, isn't it?
Yeah,
There's a lot of
very low.
And that will go. I mean, obviously, I'm not sure how. When I visited last time, Delhi, around Noida area, and even what is Rajarhat in Kolkata, isn't it? So all these new massive real estate, isn't it? That's the major user of steel, I believe, right, in India. So if you look at, so Australia story is very fascinating. That we produce so much ore, we cannot process even 5 million tons of ore ourselves. 5 million tons, because our steel production is 2 blast furnace. So one is here near Sydney, so Longdong, that's BHP, Blue Scope Steel. Another in South Australia, that's and that was struggling. One of the Indian guys, Sanjeev Gupta, Liberty Steel, he bought it and he thought he will make, but he bankrupt kind of that one. But that project didn't go well. So government is supporting that. Actually, yesterday I saw news. Australia has got here. I actually visited a couple of months ago, maybe a few months ago. This is Hobart, mainland Australia, and this is Tasmania. So Tasmania, as Hobart is the Tasmanian capital. We had zinc refinery. It's called Midstar. Trafigura company, Singapore based. They own that Midstar zinc. That's the world's largest zinc production facility. Okay, zinc required for steel alloy, right? Stainless steel. And then I think some zinc also comes from India for that plant. And also here, South Australia, that's a place called Port Fairy. So that's our lead smelting facility. That's used to be called Imperial Lead Smelting long time ago. So that's also one of the global largest lead production facility. Okay. So Broken Hill Mining Company, you heard of BHP? BHP. So Broken Hill is a place here. Actually, I visited. Quite interesting. The city, the street names are by minerals, like what they call that silver mineral, Argentine Street, or Galena Street, or there's lead ore. It's not an old name. Fascinating city because that's the birthplace of Australian mining. It's a Broken Hill proprietary. And still, so that when they made a lot of ore, they used to go during British time, so 1920s around that smelter, lead smelter was established. They transported that by rail and then produced zinc and lead and goes around the world. Still that mine going on. So this both is Minister company runs, and because I just visited from Melbourne to Adelaide. Adelaide is the capital of South Australia, and then Adelaide to Port Pirie, I don't know, maybe 2 or 5 hours driving, straight road, nothing there. It's the middle of nowhere, you're driving, fascinating drive also. So we went there. So both plants are under problem. Today I saw the news, they are going to bankrupt. So government is going to support them. The reason is that zinc and lead, two metals, are very, very strategic. Nowadays, suddenly, strategic metal concept coming in, and critical metals. Have you heard of critical metals or strategic metals? Do you know the difference? So critical metals are some of the metals like rare earths and etc. defense application. So it's not much there. Small deposits. Processing is very costly. So those are the kind of critical metals. Every country has their list, and generally rare earths. What else? Other maybe nickel. Some countries critical. Chromium. Some countries critical. But strategic metal, you want that metal, but you cannot buy it or have it because of other reasons. Like say China, last couple of months, a lot of issues going on around the world. They stopped magnet export from their country. A magnet, particularly high temperature magnet, stable magnet or primary magnet, it needs a lot of uranium. And China processes most of the rare earths. So that's why in a country like India, they are moving to that space, and Australia also. Good thing in Australia, this is such a lucky country. Any minerals you name it, we are number 1 or number 2 or number 3 or within top 5 essentially. So we don't have a lot of things, but a lot of metals and minerals. It's very rich. Actually, to be honest, India is similar land. They call it Gondwana land, isn't it? They are connected, similar, but your resources are a little bit poor quality. Our resources are a little bit higher quality. But similar resources also, India is lucky country too in that sense, I would say. But how much exploration and what way we can utilize that's the question. So that's interesting that we say it, and it's a big discussion going on. I think I 20 years my career I've seen in Australia. That we produce a lot of iron ore. Why don't we produce steel? And what do you think? Why can't we produce steel in Australia? What's the problem?
Demand of steel is less.
Our market is low, so we don't export, we don't import because the amount we use mostly we don't need, but we could export. We could be because like Japan and Korea taking our steel, and even China taking our ore and selling back to us sometimes. Production cost. Yeah. Environmental regulations, and also it's a bit of what we call it lazy mentality. We put so much
Dirty job.
just
It's a dirty job.
dig and sheep and not go down is lazy. Yeah. So, but another thing, I guess that's not the whole story, because sometimes we say Japan and Korea are also expensive. Labor, we talk about labor cost. They are expensive too. So how they make money and we cannot? What do you think? What's the reason? Japan and Korea take our role. Technology is one thing. So
process efficiency.
my feeling that I think the answer is that maybe because they have invested long time on blast furnaces and the steel plants, they written off already. In Australia, we need to invest. We don't have any infrastructure. They have already infrastructure. So that's why plant contribution costs almost nothing. You just take the ore and process it and sell it back to other countries. So countries like, and to be honest, Korea is beautiful thinking. They don't have nothing. They have no natural resources. They get from here and there.
Everything, they import everything.
Import everything. Same with Japan to some extent, but those countries, like say Korea takes our coal, our LNG, our uranium, our iron ore. So our largest trading partner obviously China at the moment, but it was Japan originally. Dropped now. So between China and Australia, $200 billion. I think 250 even. Total our minerals energy export is about $400 billion from Australia. And a country like Australia, we have got 25 million people. I don't know what's the population of Kolkata. 20 million, something like that, isn't it? Greater Kolkata. So whole Australian population is similar to Kolkata population, and we earn $400 billion every year from this mining export. So it's a good money, and that's why if you look at Western economies, Australia is doing relatively better than other Western economies. So, but on the other hand, yeah, we have got very skilled workforce. We have got so CSR, like the organization I work for. There are 6,000 people, 3,000 PhD trained scientists. We are the largest employer of PhDs in Australia. So I think that compared to say 25 million people, you contribute like you use everyone use Wi-Fi, right? Yeah. Do you know Wi-Fi invented where? That's in Australia, and CSR invented Wi-Fi. We got $1 billion from that. So, but I'm not in Wi-Fi business. I have no idea. But my colleagues, they used to do data transfer and they did Wi-Fi. Anyway, so a lot of other technologies, like I think in metal industry, the top lens, furnace, few other technologies will be invented. In the mining area, Australia would be, I would say, quite a lot of technology that people will look at, right? And those go in the mining industry. So I think but anyway, every country has their pros and cons, and countries need to look at how to develop your economy, and not necessarily need to have all the resources. And Japan and Korea is a prime example. Okay, so makes sense. And if you look at some of the little bit of that, it's out of 2024 and this is 2023. So if you look at China, power steel, isn't it? And then there are a few other companies. In Korea, if you look at this Korean companies here or not. So POSCO, obviously. So Tata is the largest. Tata is not largest. GSW. So GSW largest. How many million tons of capacity? Anyone? Any idea? 29.7. And Tata? 27. And SAIL?
20.
So that's the three main ones, right? One industry I heard that Abhijit Steel are they newcomer? Not anymore. So any other new industry in India? Steel makers?
There are small steel companies are there.
But they are small ones. We are talking about like giants like ArcelorMittal. So that's the fourth one. Yeah. So that's India. US Nucor, I think they are also selling to Japan, going to probably part of Japan, I'm not sure about. ArcelorMittal, obviously, rest of the world they are selling. And the big one is still at POSCO, that's Asian, like Korea, Nippon in Japan, I think, and POSCO. So, but that's, I think, I'm not sure, this data seems like a little bit outdated because China I expected, and again, what you are defining is that primary steel is, PhD steel, etc. So, but that's the kind of scenario we are talking about, okay? So, some of the new countries, I know Asian countries like Indonesia is going to be
Indonesia is
going up like that. Therefore,
This Brazil, I think. Brazil is also.
Brazil is quite a big steel destination, isn't it? What's that? Hale, isn't it? Hale, and also another one. So now these are the, I think, Indian scenarios. Have you seen that report? I think that was given by a colleague. So that's probably looks like eastern parts is mostly populated with steel makers, right? And some in the south, that's the power distribution. But in India, what's the specific? I have to understand also. In India, not only blast furnace, you have got DRI, right?
Yes.
And what is the feed for DRI? Iron ore? Iron ore pellets and what? Natural gas?
Yes.
Or coal gas?
We use natural gas.
Natural gas or direct? Just natural gas. Is there enough natural gas in? Is that imported gas or is that local gas?
No, we import from local agencies only.
Local
Gujarat gas, like that.
So most of the DRI plant depends on natural gas, Indian natural gas, right? That's how it is working. Okay. I was wondering that because natural gas is volatile, also going up and down, and it's quite a bit of. So what's the other alternatives? Maybe hydrogen can play a role there, or I'm not sure. I heard that some gasification and then biomass, or even coal gasification, or although coal gasification of other issues. Because ultimately DRI is, because I know the largest DRI producer in the world is India, right? Number one is that, or India and Iran, because not many countries produce DRI. Anyway, so that's Indian specialties DRI. I guess that's coal-based DRI plants, gas-based DRI plants. And what is I plant? Induction furnace, is it?
Electrical EF.
No, IF. It's a
Induction furnace.
Induction furnace. It's very small, isn't it?
Yes.
But EF is reasonable capacity.
Yeah.
Right. So anyway, so that's I've been through some of those plants, but I'm not deep expertise. I don't have any steelmaking. So one of the major use what? Automotive, right? Tata is there for automotive. Also other purposes, but automotive is one of the major. And do you know how much steel is used in a typical car in the area? Anyone? How much steel is used? 1.2 ton. A typical car, or in the plus minus depends on. If it is a sports car, it's different story, I guess, or what they call that Ferrari or those sort of different kind of luxury cars. They are different. But generally, this is one of the nowadays car makers are very efficient. They're like robotics, etc. Although I can see also various parts, steel is used. And also other small goods like say then phones, structure, etc. Other even sometimes alloy, product alloy is used. So that's the iPhone parts. I was fascinated. There's so many parts are used and different parts use different types of metal. So quite interesting. And they call it a typical iPhone production cost is it's not very good in yes, but they say that $550 and it's a processor comes from Taiwan, display comes from Korea, battery in China is a $4 for an iPhone, and total is probably various things, memory, total is they're talking about all the components total 500, and with new tariff it might go up to $800 or something less like it goes up, and it's sort of iPhone story, but that's more important for our critical minerals because in Australia, India we have two ideas. One is green steel innovation and also critical minerals, which is more iPhone type stuff, screens, etc. They use those things. So now, I was starting with why it is problematic now. Why now? Why is it problematic? In the idea that obviously we are talking about decarbonization, carbon emission. Did you see? These numbers are not very clear, but if you look at a news report usually newspapers report weather, right? Weather news all the time, what's the temperature, etc. So this is, I think, Guardian. They report. This is the first time I've seen that carbon count. Okay, have you seen that one? Carbon count. So the report. So this is, I think, I'm just reading for you. This is on 4th of January 2025, something like that. The carbon was 426. Do you know the unit? ppm. Okay, so 426 ppm on that particular day. So they report that one. No other newspaper, I don't know, in the world report what is the carbon count or carbon presence of, in this room. Do you know what's the CO2 would be? That kind of number, 400 plus minus. So they say that now it is 430 ppm. Which is a which newspaper? Sorry? It's a British newspaper. And also, this is 29 December 2024. That was just 2024 maybe. So that was not much difference. 24 and 25 maybe. They say that January 2024 422. 2015 was 400. Pre-industrial level 280. Safe level is 258, something like that. Yeah. So that's the you may heard of that bringing. What they call that target 1.2 degree, 1.5 degree scenario. So to get 1.5 degree scenario, what's the carbon amount should be? So maybe 432, 450 they say. So that's why there's a limit 450 or below 450. So to do there, it's not much scale. We don't have a lot of time, right? So that's one of the problems. Carbon emission is the problem, and then that's going up because it was 400 in 2015. So 10 years to 400 to 430. So whether we believe in climate change, that's another matter. I'm not a climate scientist, but we know that CO2 emission is going up. And why it is going up? We know that all this production, steel, everything going up, so it tracks down the positively like all these activities. So now So that's the problem, and that's why we need to act now. So my feeling is that somehow we should solve these issues that as long as it doesn't go up, because if it goes above 450 or a certain amount, you know that it becomes irreversible, isn't it? That will be difficult to get back, and it's a lot of I'm not, as I said, climate scientist, but this work going on for a long time. In CSR, if I get some literature or some work, in the 70s, scientists started working on that and looked at that. So in a controlled room, we have got now 430 here, say, or 428 something. If you make 450, the temperature of the room will go up. And that's why the global warming concept, we draft, etc. And that's all need to contribute. Now, you say that, oh, I don't bother, I don't care. That could be one approach. Right? Another one, people will come to you that will have to produce because the government has target and they will distribute it to the industries because that's whoever producing it, they have to take the responsibility and they will give the target maybe next whatever amount you are producing, you have to every year you reduce. And either you reduce it or you buy offset or something, you have to do that, right? So then it's a part of the overall ecosystem. We cannot avoid it, right? So that's why now we need to act and think and solution about that. In Australia, we had the legislation that above 25,000 tons of CO2 per facility they produce, they have to report. And now it's over 100,000 tons per year. If a plant produce, then they have to do something. So now I don't know, many of your steel plants will be under this category. Yes, power plants definitely under this category, right? So you need to think about what's the solution. So some people say we buy offset. In another country, we say in Borneo Island we preserve some forest or we plant some trees. But that's difficult solution. We need to do something locally also, right? So that's why the question is why the problem. Why the problem is now? That's the problem we're discussing about. Any comments so far? What we discussed?
The offsetting has got into a scam. Usually, if you think that they planted 1 million trees, there is nothing. So it has become
It has to be credible, right, isn't it? And time bound, long time, and how we're going to fix it, etc. So immediate opportunities in efficiency, you say, but other
process efficiency is the way to go because that is what is the long-term process. That if we are emitting carbon dioxide and buying something else there,
doesn't better to look at your plan and audit it, and maybe there are still opportunities to do something quickly.
Yes.
That's the way.
Planting new trees is difficult, but we have to stop deforestation at least.
That's one way to people think
In
about.
this road, there were several multiple aged plants,
That's right.
around 70-80 years old plants.
And
They
those
were
are
all cut
all covered because of the industrial development, because
of protecting the road.
road, and we have to have new people, we need to have new real estate, new
Yes.
land, etc. Obviously, the problem is so overwhelming. It's very difficult to think about solution, isn't it?
Actually, if those plants were there, it was purifying the air so much.
So that's why I was, as I said, I was in Brunei last week. Have you heard of that Borneo Island? Borneo. So Borneo, majority of the Borneo Island is forest, obviously. And I've been to many different types of forest in the world. I've seen that, but that is. So I drove from the Borneo or the tip of Borneo Island. The capital of Brunei is Dar es Salaam. Bandar Seri Begawan. Brunei Dar es Salaam, they call it the country. So Bandar to Temburong, a place. It's about, and there's a bridge of 35 kilometers long, 30 kilometers long. After that, Hong Kong, Macau bridge is 55 kilometers. I've been on that, you just want the car or bus. It's going forever, you do not finish the bridge. And people in Brunei is very relaxed. They said, oh, you have a big bridge, you should put in a Guinness book or something. You do not need to do that. They will say that, don't worry, we have a bridge, that's it. And they will letting single dollar just anything like that. They are very relaxed. They say, Borneo Island now they about if they are cutting trees, they have to and that's CO2 supply. But we don't know how much CO2 is in that forest. We don't. That's one way. But trees are already there. Like you said that if you deforest that Borneo Island, thinking about their pressure in Asian region, they have to reduce CO2 footprint. Three industries. One is cement plant, one a methanol fertilizer. Now they are the doctor. How do we decarbonize? Okay, solar is there, but at this land you can't end up on. Maybe not. They don't have much wind. So what is this? Maybe some hydrogen, but then you could produce hydrogen. Talking about Asian grids in Asian region has electricity. Cooperate maybe. So when they have got extra one country, they don't need. Even in Asian, South Asia, if you compare, say Nepal, India, Afghanistan, if you go there, each country has their profile, each got their production profile. Some places, say maybe during times you have got additional, they don't need, they can supply down to you. So it's a kind of, we need to have collaboration more probably. So that's another way. So I sometimes give example, I don't know what's the Indian capacity, any idea how many gigawatts capacity we have got in India?
4,54,000 megawatts.
4,000 megawatts.
4,54,000 megawatts.
So 4 gigawatt, sorry,
Around 1 gigawatt is 1,000 megawatts, no? So
40 gigawatt only, around 400
gigawatts.
So 400 gigawatt capacity, my asset, electricity asset, 400 gigawatt. How much during peak period that asset is using? Anyone?
Like peak is 246 around. Last year it was 246.
So always electricity industry, you need to have some buffer, right? Because that's so always because that goes up and down. Some parts of the day more demand, less demand. So you are maintaining your asset at 400 gigawatt. You are using at best 250. So 150 gigawatt always sitting there, right? Somewhere. They're distributed. It's not easy to harvest, but they are somewhere. So we are bringing that thinking. Okay, let's run it flat out 450 or 400 gigawatt, whatever the capacity we've got. Those additional electricity, let's make chemicals like hydrogen. So those are the times I'm maintaining the asset. Maybe I need to use more fuel, but I can convert that electricity to chemical to do other things. So maybe that's another way of utilizing the electrical assets. So most of the countries in Australia, same story. We have got 60 gigawatt capacity, but we hardly, at best, we use 32 at our peak time. So we are almost nearly double. We are maintaining the capacity, but they are sitting there. They are doing nothing. So those are the thinking we might think about. But again, where they're distributed and how you can. But ultimately, it is all about electrons. One of my colleagues, energy scientists, used to say, it's electrons. We are just millions of electrons. We are moving around. We are producing. We are using. We are transforming. Doesn't matter. As long as we can store and we can use it in a chemical form or power form or thermal form, that's fine. But it has to be cost effective, obviously. So far, makes sense what I am speaking? So that, this is the situation in Australia, we call it, what's the trajectory? So now 2025, you can see, so our net zero scenario by 2050, Australia has to achieve net zero, okay? So at the moment, the emissions is about kind of what's that, 500 million ton per year, Australian emission. So 1 year, we produce that much, we emit that much CO2, 500 million ton. So that was actually a little bit high, maybe 550, that is going down now. So that resources, agriculture, built environment, industry, transport, energy is significant, that because all is still fossil-based electricity, some quite a bit, and the land use or land clearance, that I don't know why that is that's negative, isn't it?
Yeah, this is one of the sequestration part.
That's you can put in the land,
yes.
and you can claim
And
for
I
credit
use that how much I save.
credit for that. Various ways you can utilize that forest conservation.
Yeah, there should be a balance between the consumption and.
That's right. So now, that's Australian scenario. We are saying that by 2030 there will be a scenario. You can see that energy component is going and thinner, right? So that's the one target. That means decarbonizing power. That's one message it is giving. We have a transport same story. Transport. Generally, rule is one third transport, one third buildings and others, and one third industry, probably, isn't it? Something like that. So you need to, and again, power is produced. You guys are producing power. Those are in the power plant. It is going to be steel, and if you calculate the CO2, the power you are producing that has got CO2 footprint. they are taking CO2 to the water, to the electricity, to the steel plant. So when you calculate is CO2 or your CO2. How do you differentiate that? You shouldn't double count, right? That's the story. So kind of plan has to be separated. So that's why sometimes the uniformity is required. So that, but you see 2050 scenario, we are saying lots of storage like your land maybe or other reserves, offsetting reserves. So that's why we are taking CO2 from the atmosphere and buying underground or something. So that is one way. And you can see only transport a bit, and what is this one? That industrial waste a bit, and maybe energy. So another thing is that we can make electricity from renewables completely decarbonized, say 100% renewable. Some countries can easily do that. Australia at least can do that, I can tell you. But electricity is not the only source of energy we are using. What about heating? What about industry? What about others? In Melbourne, if you look at Melbourne electricity need, is half of the electricity, or 60% energy goes for space heating and cooling. Because so that's if you electrify everything, still the solution is not there. So that's why steel, for example, steelmaking, for example, you have got reductant, right? Carbon you use, you cannot avoid that. So some people it hard to abate sector. So you don't have choices really. So how you can do that one? And then there is CCS, carbon capture and storage, those sort of storage coming. So you can make your plant 100% efficient. Still, maybe you cannot really make good reduction because of all these reasons. So each industry has their own unique kind of activities, and we need to understand that, and the industry experts need to understand that. Their own industry, how you can minimize, may not be same for another industry. Does that make sense? So far what I have spoken about? And I'm not sure about this one. This is limiting warming. So that's all. That's one net zero by 2050. This one, if we want to limit warming to below, not more than 1.5 degrees, so 1.5 degree less. If you want to keep like that, maybe you can look at that. So that one is probably 150, something like that, isn't it? 150 million ton. This one is you have to have a drastic emission. So that is just net zero by 2050 scenario, and this is if we want to limit 1.5, we have to be more aggressive. So it looks like that is only, I think looks like industry weight still there. This one is probably my is that what agriculture? Is it agriculture? We cannot avoid agriculture maybe, so you have some food on the table. So it's a quite tricky game, and I wish somebody have that kind of graph for India. They might have, right?
Is we have a net zero 2070.
2070. So your one is more further down there, right? So because of the development, because of the industrial situation, because of the economic condition compared to Western countries or developed countries. So these are the things it was not well understood, say in 5-10 years ago. If you ask someone, nobody could answer this one, right? Now at least we have got a good understanding. But next step is that how precisely you can do this kind of calculation. That is required. And I wish that is for country, you can have your own company. How do you do that? Even the energy development. Nowadays they call it organizational LCA or organizational carbon footprint. And in these cases, whoever working for these companies or these industries, they have to have good understanding of this kind of graph for themselves. Okay? So
our cost in Australia.
sorry, Parth, I'll show you maybe one of the slides we have got here. So if not remind me sometimes, I'll ask you, I will give you the answer. So this is Indian emission, right? Is that, I don't know, is that number signals right? 3 billion ton. I don't think so. Is that too much or too less? Because globally, how much? Do you know? 28 billion ton, I think, something like that, isn't it? So is India 10% of global pollution? I don't think so. But anyway, they get somewhere. So it was very low until 1995, and then suddenly picked up. And then, but is that emission? It says that global carbon budget, fossil emission, major quantity of carbon dioxide emitted from the fossil fuel directly from industrial processes, cement and steel production. So that looks like what major contributor. Fossil CO2 includes emission from coal, oil, gas, flaring. You know flaring, right? So gas industry. Cement, steel and other industrial processes, fossil emissions do not include, I think I know that land use changes deforestation soil. So except land use, these are the emissions. So but that much, it's like zero kind of exponential, isn't it? Yeah? So if we don't do anything, it will go like that, to the roof. If I literally to the roof. So yeah, I think there are challenges. So that's why why decarbonization is important. I don't think I need to convince you, right? Hopefully, obviously, you need to convince the politicians, the policymakers, and that's another level. But at least if you say ordinary people, even those who work in the deep into this kind of area, we didn't know that. And this data is new to me kind of. But how quickly, so if you look at the data, that speaks kind of. And then that's Avash's work, Avash calculated. Avash, can you explain this? Come out and explain this graph.
Previous one, right? When the US factor.
So you can use the microphone or
No, this is the point.
you can use the microphone also.
Basically, we have done a report, or I think maybe previous or back this one. So then total steel generation by steel industry in India. We have calculated that last one is there are 11.2 million ton of CO2 produced. And if you scrap GRI, then 9.2. And gas GRI is 10.24 DRI. Why? Because things like that in India we are more producing CO2 generation in last months. And it actually there are existing blast furnace we have in India. That's why we are more polluting CO2 generation. Rather than scrap GRI and gas GRI, we are figuring out that scrap EF route. So let me say that how we calculate the CO2. We are calculating the CO2 scrap. Is the rather scrap speaking of is recycled? No. The answer is the scrap is coming also is from something, the life cycle of previous one. If we calculate the scrap on the previous one, this also has some CO2. And we have calculated the Simacro software like that. And how the scrap is having the EF route, how much consuming 19.2 kg of CO2 like that. And if we calculate gas GRI, this 7.24 is very makes sense, right? So with coal-based DRI, we have calculated 2.4 million joule. It makes an example that we have plant situated, right? We have plant and we are having the steelmaking route like GRI using coal-based DRI. And only we have mining operation to how mining is consuming some CO2 emissions. We are doing some calculations because of CO2 emissions. That's why the coal-based DRI route is rather than less than the other DRI unit. And that's why we calculated some of this one data. We have done the potential report. We have done potential report from different ministries, and finally we presented in the international conference, the TMS in US, and we have worked together. Right. That was there.
Thanks Avash. So anyone can add anything else what Avash has spoken about, or can anyone? Do you think you refute that, or you have new data or information? Does that make sense to you?
Actually, you not understand that whole DRI EF that is killing, right? 2.4 million ton of CO2. Based on what amount of production that is?
Based on Indian stat in particular year, I think we can give more details.
For a particular year, of the whole DRI EF is 2.4 million ton of CO2.
Yep.
But
So that's-
then,
so
what
part-
do you
part-
put?
No, half part.
It's not, it's
No,
not.
that is part
It is-
of
it is-
whole
it is-
DRI times the amount of DRI
Yes.
used in that country. That's the total.
Yeah,
Okay.
that is it.
It is for the entire country for a year,
For 1 year.
for 1 year.
1 year. Does it make sense, or it's maybe small or more? Any idea? Because we might need to look at that
It
data.
can be like 2.4 metric ton per ton of production of steel. That
No, it is.
No, that is not metric ton, because in the BF route it can't be 211 metric ton.
So we
This is
had that
actually,
one.
this is multiplied by production. This is the production, that's BF route is the total
Highest.
production in India multiplied by third-party CS.
That is for the entire
Entire year. So you know that we had 140 million
Yes,
ton,
that-
149 million ton.
Yes.
That is not only BOF that has got small,
Yes.
mostly BOF. That's why it is the main one.
88%.
But there are a small amount other types of steel, and each has got its specific footprint. We multiply it by
Yes,
the total footprint,
that
and
is
that's the
the-
way we distribute it.
But I believe the coal DRI EF route should be
Higher.
higher.
My
Specific
feeling is
specific
that
area
goal
should be higher.
So, but we have to
Also,
change
this
that.
data is, I think, it's some sort of, I don't know, it's
So, a lot of
misrepresented.
judgments, getting data and judgments.
Misrepresented.
So maybe I don't know coal DRI, gas DRI. So, but Avash, you think?
So these things are data which is generated, right? It's a software data and engineering data. One thing more which need to add to know, in this data, something parameter will be fixed. What the parameter fixed? There's a parameter is fixed, some parts are fixed, like mining is fixed, some part is transmission is fixed. So if that is actually correct, that data is 2.4 million ton, or maybe 5.5 million ton. So
No, I'm not challenging that data.
No,
I'm
it's
just
just
saying that.
It sounds like coal DRI is
Yes,
low.
yes,
It
that's
could be
specific.
higher.
No, if we go about, if you want to really calculate and make some impactful change, the specific consumption should be, the specific generation should be considered.
Okay. So
Or-
there is
not
another
the total case.
Or we have to write the total production.
Yeah, we
We
could
have
have
to
another
total production.
Yeah,
two column which is
total
one is
production,
production.
that's what.
Another is characterization factor.
Yes.
This is called the
Yes.
footprint.
So
I think we can have that number. We can have that number, but we can. But anyway, I don't think many people thought like that. We didn't see in literature or just because one is the specific footprint, another is total production of that amount, and that's a concept. Because we say, okay, in India we want to decarbonize the steel industry. Where we attack as a first, we should attack here because that's the we can obvious that's the thing, and then small bits and pieces you can go on there and so forth and so on. Okay, so that's the obvious thing. When you analyze and put the data, sometimes it comes like that. Now, with some of the headlines, that that's interesting times, right? It's not. It's very recent. I think they call it. What is that? Barnier Hut. Is that Barnier Hut or Barnier Hut? Have you heard of that place called? That's in Assam. So that is apparently most in India, and people get that is a lot of industry in that part of the world, and somehow that is trapped within a kind of all the sites are mounted, and the industries are there. So that pollution gets trapped, and some reason that people get sick and etc. So anyway, that's one place, and then Delhi, obviously New Delhi, etc. And you see. So I think the 5 is the. So 5 is the standard, so how many times more, and that also goes up and down anyway, right?
It's a AQI or what?
Sorry?
It's an AQI or what?
This is particulates 5 PM to
PM.
25. So anywhere, I mean, this is not, I'm just not showing, it's not my objective to say which is bad, etc. It's many parts of the world if you go, that's the scenario, right? And you see the best air quality since September 29, and then October started 2024 and up to June. You see that's good is we short that one 0 to 50, okay, right, that's the mark. Satisfactory, moderate, you see majority of the places and some parts of the that's pretty problematic. So it's not only decarbonization, other problems are there too, and that's maybe it's I mean climate change, decarbonization. Some people do not believe in climate change, you know that, right? Although majority of the scientists believe, and now it's so established fact, still there are a lot of opponents that doesn't matter really. But forget about that. What about the air quality? I mean, sometimes people say it's not that some of the cities it's like gas chamber. If long time you stay, it's problematic really. So you need to do something about that. So that's but in the beginning, at least good thing that sensors are lying, they're measuring and they're reporting those numbers, right? So that's not made up number. That's a real station sensor is measuring day and night and reporting. So now that's a problem. We can tell a living problem, but what's the solution? That's another problem. And you can see that one Delhi is to 10 emission target report, and that's Noida. That's they have put a reduction, I guess, but I think Delhi is less reduction. So that's again PM10 in 2024 and PM10. What was it in 2007? So that was high, that reduced. So something getting done, good work. So if we continue to good work, maybe we can bring down further. I guess, or around that very low mark, as low as you can possibly can get. And I don't know what they call that is can anyone say what is that?
Gradual reduction action plan.
Action plan, that's right. So how you, if it is certain AQI, what you do, right? Graph 1, graph 2 is that, graph 3, if it is AQI, 350 plus, you cannot do a lot of things, right? You cannot drive a car and this and that. So now I know Delhi government knew they're introducing EV, right? Electric vehicle.
Yes.
I have gone many cities in the world. I think I don't know how many airports I've taken in my life and how many hotels I stayed. It's quite a fascinating experience, but each city has got its own plus minuses. And many cities now introducing EVs, and EVs thinking EV is the solution. Some cities introducing hydrogen fuel cell vehicle. They are the solution, but actually it's a mixed solution, I guess. So it's not one solution fits for all. What I recommend for Delhi, maybe not right for Kolkata, maybe not right for Melbourne, maybe not right for Sydney. So we need to have different solutions for different places. Okay? So, good thing, also good things happening. I mean, that as I said. And what is the good thing here? This is the private sector industrial generation capacity by source as of 2013 India. This is India actually, right? This Indian data as far as I know. So coal is 86 gigawatt. You said 400 gigawatt, right? Total?
It's just the private sector.
I know.
If you-
So that's right. I'm coming there. So total of 486 just private sector, right? But if you compare that with solar number, 67 gigawatt. Wind number, 42 gigawatt. This is a good number. A lot of people are investing in technology, new technologies, renewable technology. These are all private money, right? So suddenly it becomes, I don't know, do they get money from government? Maybe not. Maybe subsidy, they get.
For the
So
solar
because
energy,
solar
they
energy
subsidy.
is a subsidy. from
Subsidy
government.
when you sell the electricity.
No.
No,
Yeah,
yeah,
what-
yeah,
what-
yeah,
what-
yeah.
Also, when you
Yes.
invest, the capital cost you get subsidy.
There are some programs like incentive programs like RE certificates, that renewable energy certificates, that those who are producing they get the advantage of. They sell it to the some kind of obligation are there for the thermal industry to utilize some renewable energies also. So because of that they get some incentives. Private
Whatever
sector
they're doing,
incentives.
that's working, right?
Yes,
And incentivizing, same with the hydrogen industry. Billions of dollars imported in Australia. If you produce green hydrogen, you will get $2 per kilogram tax incentive. In US, it's $3. So if your cost is say $7, $8, it suddenly becomes half. You are kind of it's $2 target. You are near there. So initially maybe you need that subsidy. Later you might not. In my own home, I have got 6.6 megawatt solar, 6.6 kilowatts. Sorry, not megawatt. Megawatt is new, you know. 6.6 kilowatt, 5 kilowatt inverter. So limit is 5 kilowatt. Even I am producing 6.6, 5 kilowatt limit. So it goes like that, flat, nice sunny day. It's like it should be bell curve, but it is goes like that and then flat and then come down. Every day like that. So my 5 kilowatt system produce about 8,000 kilowatt hour per year, which is my own need about only 3. So 3 times more I produce. So I produce my own need plus my neighbors, 2 neighbors. Okay. So
You get it to the grid.
fit into the grid when there is no need. So and also I have my another professor, Professor Firoz Alam, who is a good friend of mine. He has been here too in the book. He is a professor in RMIT University, one of the university in Melbourne. So we both have solar, and it's like scientists, we do things ourselves. You know that one of the in Australia, Barry Marshall, he got Nobel Prize for one of the bacteria discoveries. So he drank himself. So we kind of do that in ourselves. So we have that data we are collecting for a long time. I'm collecting at least last 5 years. Professor Firoz Alam, his house is collecting. So it's a real data we have got. We pay the bills. We don't depend on anyone else. We say, oh, reliable. So our own data, money goes from our own pocket. So when I invested, I got some subsidy. Still, last year I didn't pay any electricity bill. $90 came in my pocket. I usually pay $1,200 per year. Second year, sorry,
How much?
$1,200 per year. Okay, $1,200. So first year I didn't pay. Some money came to my pocket. Second year I think I paid $100 net. Third year with $600. Now I pay nearly $1,200 because that incentive has reduced. So they treat us like a generator. Okay? So previously they used to have incentive, and now they treat us. So when I buy probably 25 cents per kilowatt hour. You asked the electricity cost.
25 cents
That's
per kilowatt.
residential, 25 cent, 30 cents some people, 30 cents per kilowatt hour. When I sell it back to the grid, it's 3 cents. So 10 times more when I buy, when I sell, nothing more. So now, because Australia is a large penetration of solar, each house, and we have got big houses, obviously, the solar, there are 24 panels, so 4 million households out of roughly 10 million households in Australia, more Australia, less than 8 million. So half of Australian household, everyone has got a solar. And that I was going to talk to you that during lunchtime we used to say, oh, never will happen. Suddenly something came about, everyone has got solar. So now problem is that during daytime we have got a lot of electricity production, because if you look at what is called dark curve, I think all these are power or people, colleagues know that one. So in the morning we got until say 12 o'clock to midnight to 6 o'clock or 7 o'clock, not much electricity used, only few appliances used, right? And then we woke up and then suddenly it goes a little bit up. Both of my wife and my work will go outside, my son goes to the uni, my daughter used to live with me, not anymore. So and then suddenly nothing, no electricity, but solar is using, solar is producing. And then you go and then when you come back, it goes up again. And that will not have power. So I can draw from the grid, right? So that's the kind of scenario. So now, the Australian government is giving the batteries rebate. Because if I can use that one, and as I say
Buy the batteries.
say my wife during when there is a sun, okay, run the dishwasher, run the whatever you want to. So do the cloth the dryer, things like that. So you don't pay electricity because that time solar is coming. So and it's a 4 million household. Because our power plants, we could probably take maybe a couple of coal-fired power plants off the grid because of the solar. But you have to manage that. And now we are saying, okay, the scenario like that when I've got solar high, let's make hydrogen. And then all these houses make hydrogen stored somewhere. So it becomes chemical, you can use that at night too. So that's the kind of strategies people are thinking about. So it's not necessarily there is no solution. There are solutions, but you need to be a bit creative initially, maybe some incentive. So I think it's also people's mindset, and we thought it would be very expensive. I got my money back almost nearly within kind of last. If they continue the same debate, I would get my money back by now. But now because I don't get much really, I have to wait probably for a while. So these sort of things now in Australia, solar power is not a matter of vision. It's already well established. There are residential, there are most of the mine sites, they have got solar plants. It's a big plant, solar wind. So that's the way it is moving. So if you look at this one, I think that was when I came last time. I got a newspaper, I was reading, I got a photo of that. So that was 2023, I think is that, as of 2022. So that was coal was, what is that? 2
lakh megawatts.
gigawatt.
200
gigawatt.
200 gigawatts.
203 gigawatt out of that, so that is 2022. And if I go back, so that was 86 is private now. I don't know that time how much private was that. But you can see significant sort of that way. But look at solar and wind. Solar is 61 and wind is 41. If I go back, solar is 67, wind is 42. So that means
Equal.
More or less.
so they are said, but must be this. They didn't see whether it's private or public. So my feeling is that that is
Private there are more.
more.
The solar and
Always
wind.
private is more, right?
Solar.
And they say when we go back previous that are not available, whereas here it's a small number, not much. Nuclear is probably static at 7, something like that. So this is, you are very familiar with this, right? So now, actually last time, in my course, last LCA course we did, what I told the students, okay, get another column and tell me what is the CO2. You should be able to calculate, right? How to do that? Any idea?
What is CO2?
I want to know what is the, we know the megawatt, I need to to know what is the CO2 or total CO2 from this system.
For coal-based thermal power plant, once I have calculated, like for 1 million unit of electricity generation, there is approximately 900 ton of CO2 emission per 1
Megawatt hour.
1 megawatt or not, 1 million units.
1 million units means 1 megawatt hour, isn't it?
10 lakh units.
If
10 lakh.
1 megawatt hour runs for the 24 hours, that will
I see, okay.
produce 24 million units of electricity.
Right.
That's all. So for 1 million units of electricity, there is production of 900 tons of CO2.
Right. So what the way we do that, I tell the way, I don't know, maybe that's another way to do that. There are a number of ways.
Because the usage of electricity is in units like million units or kilowatt unit.
Kilowatt hour is
Unit
Kilowatt hour.
So that way.
So what we do, I mean, I told the people to put another column and see the running hours per year. So maybe coal-fired power plant running 8,000 hours. Okay, this is the capacity factor. What's the typical capacity factor for your plants?
The thing that we can do is like how much million units of electricity has been generated. Out of that 203 gigawatts of installed capacity,
How much net electricity
is generated by the client in a year? In million unit terms.
So you have got that record, right?
Yeah, we get the record. Like in India, like in the entire world also, the electricity utilization or the generation is calculated in million units only.
Yep.
The installation part, the installation and the product, installation of thermal plants are done in megawatt part, but the generation is done in million unit part only.
That's right. So that's, I understand that. But what I was saying that say coal that many megawatt year capacity, and it obviously if you know exact electricity power sent out in million kilowatt hour unit or million unit, that's fine. But sometimes what we do generic, we have to do calculations. So what I say, just say the running time, and running time usually 365 days, 24 hours, but you cannot never have that one. That number you multiply 365 days by 24, it will be 8760. Okay, that's the total. So 8,000 divided by 8760 is maybe, I don't know, 90% capacity or something.
91%.
So maybe qualified is too much. Maybe 80% is right number, right?
80% most.
80% is right number. So maybe 7,500 hours or something like that. So that one, I say that's coal. You multiply by that many megawatt hour electricity will be generated, hopefully, right? And 1 megawatt hour electricity generated means 1 ton of CO2 for coal-fired power station. Plus minus, it depends on what type of coal and there is. So generally say 1 ton or 1 kilogram per unit or 1 kilogram per kilowatt hour unit of electricity from coal-fired power plant. If you go, Javash said that
Yes,
database, roughly.
Approximately, I said 0.9
1 to 1.
Yes,
1 to 1. Or it's a 0.9. Yeah, similar. So then you can know that one, and you will see that roughly quite significant will come from that, and that's why we saw previous Australian data. Energy companies are one of the major emitter because of that reason, right? What about say lignite coal? Coal is coal and lignite similar, low quality coal, maybe a bit high emission factor, right? One instead of 0.9, it will be probably 1.2, 1.3, 1.15. Gas. Do you know what's the gas factor? So it's a 0.7, generally 0.7. So if you know that one, you calculate diesel, similar, diesel will be high. Solar now. Solar, do you have an idea how much? Where is the emission solar come from? I don't know how we are going to time hours.
like production of
1 hour
production of panels.
1 hour done. Okay. So sorry. So you can basically calculate solar. You can go a little bit more later because that's the whole objective. How you do each has got a different way of calculation. That's all about this course and that about LCA. Okay, we'll come back to that. So I think that's towards the end of this module. It's a complex problem. We think very simple, but it is not simple, right? Each of these production has got its own uniqueness. Customization is required for location considering various factors. Carbon emission reduction possible. We should show that one. Net reduction quantification using life cycle assessment methodology because we need to keep the same language, same boundary, same everything. And that's why we need more course like this. Cost has to be considered with technical evaluation. So it's not only CO2 reduction, you need to have that one. So that's why we need this skill manpower and retraining is required in startup industry. So not a lot of people. I have spoken with electrical engineers, they don't have an idea or they struggle, because a lot of my engineers nowadays, I sometimes I question about the engineers, I don't know, curriculum or whatever, they do not know that basics, that, 1 kilowatt hour of electricity coming out of coal, if you multiply by 3.6, it will be 3 megajoule. It's not 3 megajoule. It is probably starting with 10 megajoule because you have got what they call efficiency factor, right? Or the etc. So that's a lot of people do not appreciate that. We need to understand that. Okay. I think that's it probably. So let's have a quick break, come back, and maybe we can